right, so today we are in lesson 1B, and what we're going to talk about today is just displaying and describing categorical data. So if you remember from our last lesson, categorical data is just data that has no numbers. So it's things like colors, or in this case, we're going to do an example here with fast food restaurants, okay? So first thing that we have here is that this is going to be a frequency table. A frequency table shows the number of observational units having each value of a variable. And so we think of this most often when we think about frequency, we think about counts. So to kind of look ahead here, we've got this example down here where it says, Mr. Oyster asked the students which fast food restaurant had the best chicken sandwich. Here are their responses. So what we have here is this series of fast food restaurants. So I'm going to start by making a frequency table. So what I'm going to do here is I'm going to put the restaurant and I'm going to put the frequency. And again, frequency, think of frequency as count. So I'm going to have Chick-fil-A, it looks like KFC, Popeyes, and Shake Shack. Okay, so those look like they're the 4 restaurants that are up here. And so when I look at a frequency table, I'm just literally going to count these. So I have 1, 2, 3, 5 for Chick-fil-A. Looks like just 2 for KFC. 14 for Popeyes. And 6 for Shake Shack. Okay, so if I add all of these up, this is going to be 27. So if I counted all these, I need to have 27 restaurants. Okay, now once we have this frequency table, this tells us just how many people chose each one of these restaurants. But from the frequency table, now we can create something called a relative frequency table. And a relevant frequency table, it tells you right here, it shows a proportion or a percentage. And so when we do this, we have the count over the total. And so what we're going to do down here, we're going to create another column right here, and this is going to be our relative frequency table. And this is just going to be 5 over 27. And then 2 over 27, 14 over 27, and 6 over 27. And this, we can leave this as a fraction. We usually don't. We usually want this as, because this is technically a proportion, but we normally want these as a percentage. So if you plug this in your calculator, 5 divided by 27, I would get a relative frequency of 0.185. Okay, now sig figs aren't important in stats. We're normally going to go to 3 decimal points on everything just because as our numbers get smaller or bigger, we're going to do comparisons, and so that's just what we've had. So this is my decimal relative frequency, but I could also show this, remember, I could show this as a percentage. So this is the same as 18.5%, and this is the same as 7.4%, 51.9%, and 22.2%. And this really just matters how you want to see these numbers. So just to kind of write this down, here I would have this as a proportion, and here I would have this as a percentage. Okay? All right, so let's keep going here. So down here it says, do these data support that the claim that the majority of Mr. Oyster students think that Popeyes has the best chicken sandwich? Now, this word right here, majority, is a very important word in stats. So majority means more than 50%. Now, we have that. We have 51.9%. So the answer to this would be yes. And remember, in stats, we're going to write everything out. So the data shows 51.9% of students think Popeyes has the best chicken sandwich. All right, now I'm going to make a little note here because this is important. Majority is not which one is the biggest. Majority is also or only greater than 50%. Very important concept right here. Okay, are the frequencies and relative frequencies in the table from part A considered data? And that's a tricky question. So it's asking these numbers right here, is this considered data? And the answer to this is no. It's not data. This is just a summary of data. Now, you might ask, okay, well, what's the difference? Data is going to be something that's going to be calculated or driven. So this would be my data that's up here. The problem is that this is not numbers. This is just give me an answer. Which restaurant do you like? And so when we summarize the data, all we're ending up with is a summary, not the data itself. We're just saying yes or no, do you like Chick-fil-A? Okay, let's keep going. All right, so when we display categorical data, now this is important because when we get to quantitative, the way we display is going to be different. So when we display categorical data, we're really only going to do this two ways. We're going to do this in a bar chart and we're going to do this in a pie chart. Okay, a bar chart is a graph where one categorical variable that displays each category as a bar. And then the height of the bar shows the frequency or relative frequency. And remember, this term frequency is the same as count. All right, so let's do an example here. A total of 55 modern Olympic Games have taken place since their inception in 1896. Summer and winter games occurring once every 4-year cycle. The games canceled by World War I and World War II have not been included in this frequency table. It summarizes the distribution of a region in the world where the games were hosted. Make a relative frequency bar chart to display the data. All right, so right here, relative frequency. What we have here is not relative, it's just frequency. So I'm going to go in and I'm going to calculate this. So to do this, I know there's 55 games. I've got an old calculator because I'm doing this at home right now, but I'm going to have 8 divided by 55. So I'm just going to create my relative frequency numbers right here. So here's my relative frequency, and I've already done this just to save time. Now, here's something that's important when we look at relative frequency numbers. If I add up all of these numbers, this needs to be 1 or 100%, depending on if you've got it as a proportion or a percentage. So I'm just going to add these up, 0.145, 0.582, 0.218, and this is 0.999. Now, this is technically 1, and the reason why it's not exactly 1 is because remember my numbers that I have here are rounded numbers, okay? Now, I'm going to show you another way to do this in your calculator, and I think it's going to be super helpful for what's coming. So go ahead and write this down here when you see these calculator steps. So the first thing that I'm going to do is I'm going to put the data into my calculator, and I'm going to show this to you two ways just because I think it's faster. But the first thing is I'm going to put in just my counts, just my frequencies. So you're going to go to Stat, and then you're going to hit Edit. And you're going to have these different lists, this list 1, list 2. So the first thing I'm going to do is I'm just going to put these numbers in, and you just type the number and hit Enter, and you've got your numbers right there. Okay, so I've got my numbers. Now what I'm going to do is I'm going to calculate the relative frequency. So instead of just plugging this in my calculator, I'm just going to go up to the very, very top up here. And I'm going to tell it I want you to take list 1. So to do that, I'm going to do second list. So second stat. So remember, the blue gives you the list, the number that's above. So second stack is list. I want the number that's in list 1, and I'm going to divide this by 55 because I have 55 total. So if you look what it has down here, it says list 2 equals list 1, which are these numbers, divided by 55. And now when I hit enter, it went ahead and populated all of this for you. So it's just a quick way to get the calculator to do the work. And the other thing this helps you with is you don't have to worry about transposing a problem on there. Okay, so then the next thing that we're going to do is we are going to look at creating our bar chart. So when we create our bar chart, we're going to use relative frequencies. So I'm just going to create this little chart right here. I've got to come up with an axis. So my axis is going to be my relative frequency, which I could also list as a percentage, or I could list as a proportion. Either one of those are going to work. Since these are decimals, I'm going to leave it. So I'm going to say 0.1, 0.2. I can stop at 0.6 because that's my biggest one. So down here, I'm just going to go left to right as I put these in here. So my first country is Asia, and it was 0.145. So I'm going to have a little bar chart that's going to be almost 1.5, and that's going to be Asia. My next one is Europe, 0.582. So that one's going to be clear up here, and it's going to look like this. Okay. My next one at 0.218, that's this guy, and it's North America, and then 0.036, so we got this little tiny one that's down here, and that's Oceania, and then even smaller, clear down here, I'm going to have South America. Now, I'm going to show you how to do this in Desmos and in your calculator when we get to histograms, but as a bar chart, this is how we want it to look for this. Now, let me tell you something that's super important. When you're doing a bar chart, the order on the x-axis doesn't matter. So if I'm looking at this data and I look at this data, I can say, okay, well, we have a peak here for Europe, and then this is really super small here down for South America. If my numbers were changed up, my peak might be here if I had Europe first, or if I wanted to put them in order, smallest to greatest, my peak might be up here because it was the last one. So I'm going to make a little note because this is important, super important actually when we get to quantitative data, but categorical data doesn't need a specific x-axis order. Now, because of this, because we could have put this in any order and we would still see the same results, this means we can't describe data trends. All we know is that Europe had the most. We can't describe any sort of data trend, and this is going to come back here, I think, in our very next lesson. Okay. So you can use a bar chart or a pie chart to describe the distribution. So all we're saying right here is that we're going to talk about what's happening. We're not going to talk about the trend, okay? So we're just going to say Europe's the most, South America is the least. Can you see this over here? You can, yes. Now, because the AP test is all digital, you'll never have to draw this. However, it's important that you're able to look at data. Sometimes you may need to put together a bar chart or histogram so that you can look at the data, okay? A pie chart, on the other hand, is a graph of data for one categorical variable that displays each category as a slice of the pie. The area of the slice is proportional to the category frequency or relative frequency. So you can see this as a proportion, and remember, proportion and percent, we're going to talk about those being interchangeable this year. Okay, a bar chart or pie chart that displays a distribution of categorical data must include all observational units. Now, for an example, we don't have Africa on this list. And so let's just assume, we know this is not true, but let's just assume Africa didn't have any Olympic medals. We would have over here Africa listed as our category with nothing there, okay? The reason why we didn't do this is because it's not summarized in our table. So, I mean, we're not going to include it, but if it was over here, even if the total count was 0, we would still have to put it on there, all observational units. Okay, so here we go. We have a pie chart now. So here's our pie chart. So the first thing it says is this Nelian Audio surveyed these radio stations to identify the kinds of programs they broadcast. What do the majority of radio stations broadcast? Well, if we look at this, it gives us the genre all the way around here, and it gives us the percent that is broadcasted. So this is a great example of an AP question. What do the majority of radio stations broadcast? This is a trick question. Majority. Majority, remember, is greater than 50%. So if we look at this chart, we're going to say none. So the reason why this gets tricky is because most people are going to say religious music because it's the biggest piece of the pie, but that's not true. So it's none because all are below 50%. All right, so now, what is the most common radio format and how many stations does this include? So religious is our most common at 22.14%. But that's not what the question's asking. The question's asking, how many stations does that include? Well, we surveyed 17,330 stations. So what we have is 0.2214. So we change this back into a proportion or a decimal of the 17,330 stations. So when we plug this in our calculator, oops, sorry, not sure what I did here. We get this as 3836.86 stations. Now, we can't have 0.86 of a station, so what we're going to do is we're going to round up, and we're going to say 38.37 radio stations. Now, if this was on a free response question, we would really say 3,837 radio stations broadcast the most common radio format, which is religion. Okay, so be very specific if you're on a free response question. Okay, so comparing distributions of data. The whole reason we collect data is not just to look at this, but to actually draw conclusions and analyze the data. That's what makes stats so great, is we get this data from somewhere and then we actually do something with it. You're not just giving us a number. So when we compare, one of the easiest ways that you're going to see with categorical is side-by-side bar charts. And this is an example of this. This is a side-by-side bar chart. So we're looking at a couple of different things. It says, this research center asked a random sample of U.S. adults what they thought the best age for a U.S. president would be. A side-by-side bar chart summarizes the response of 18 to 29-year-olds and 60 to 69-year-olds. Compare the distributions for the best age of a president of the two groups. So this goes back to like ACT prep. So here's what we have. We have two categories. So I have a category 18 to 29, and I have a category 60 to 69. This is the percentage that thinks that the best age for the president are these different ages. So what we're going to do here is this word compare. You literally are going to compare the two. Now, do you need to go bar by bar? You don't. But what you want to do when you do compare, and let me make a little note here. So compare, we want to use actual descriptive words like greater than or equal to, and we're actually going to compare the two. We don't want to say is bigger or is smaller. Those are words we don't want to use. We want to use greater than, less than, equal to. So what I would do when I look at this is I would say, okay, this is the highest and this is the highest, and they're both this blue hatched. So I would start by saying both 18 to 29 and 60 to 69 believe the best age for a president is in their 50s. Okay, so we're saying both, so that's another descriptor word. So we say both believe that the best age for a president is in their 50s. So some 16 to 29-year-olds believe a president in their 30s is ideal. None of those 60 to 69 believe so. That's another comparator. The other thing that I can say is most 16 to 29 believe 50 years old is the best age. Whereas, this is another comparator, right? So whereas, oh, hold on, we just did that one. Let's do another one here. Let's look at this red category because there's significant difference in this red category. So believe, I'm going to say 40. So I'm going to just change this up. So many 16 to 29-year-old believe 40 years old is the best age, which is greater than 60 to 69 years old. Now, I could keep going. I could keep doing this distribution, but all we're doing is we're comparing one bar to the other bar of the two different categories. Okay? All right, let's keep going. Misleading graphs. So this is important because a lot of times when you're looking at data, you'll see something like 98% of all people saw improvement in skincare after using this cream or whatever, right? And when you really look at the data, it doesn't make sense. It's a marketing thing. So let's look at this graph. So I know this is kind of difficult to see, but this is 95, 96, 97, 98, 99. So this is in one percentage. And it says more than 98% of all Chevy trucks sold in the last 10 years are still on the road. So how is this a misleading graph? Well, if you look at this, it looks like Chevy is significantly higher than Ford, right? But if you look at the scale over here, Chevy is just barely over 98% and Ford is 97.5%. So we're talking about less than 1% difference between Ford and Chevy being on the road. So what makes this misleading is the scale. And so all pictograms and bar graphs, and a bar graph and a bar chart are the same thing. All pictograms and bar charts must start the Y scale at 0. Okay. Another way we get misleading data with categorical data is a pictogram. So this is a pictogram down here, and a pictogram displays the results of the data by using a picture. So if you read this, it's just asking if we converted people in 1998 to an iMac, They want to know how many of those people were previously computer owners, were previously Windows owners, or had a Macintosh and they were going from a Macintosh to an iMac. Okay, so if you look at this data down here, it looks significantly bigger. So when we look at this, if you look at just this none bar right here and you look at the size of that, if you put the size of those in here, and of course I'm just roughly sketching this would show that would be 3, 6, 9, at least 12 times bigger, right? Because what you do when you look at a pictogram is you look at the area of the picture. So let's see if this data makes sense. So if we want to look at percentage, remember percentage is the count over the total, and it tells us up here, I know I didn't read this, but it tells us we have 500. So this is going to be 85 over 500. So this is going to be 0.17, 0.12, and 0.71. Okay, so we're talking about 17%, 12%, and 71%. That's what we have. So if we look at this value of 17%, and the area of the picture is about 12 times our area of our none, well, 12 times 17 is much greater than 71%. So what happens, and what the key takeaway here is, beware of pictograms. Don't use them. If you see them in an AP Stats question, it's probably going to be a tricky question. And what you want to say is, don't use pictures, just use bars, right? Even though the scale was funky, it gives us a very good distribution of what's happening, whereas when we look at the area of this, it just doesn't make sense. So beware of pictograms and watch scales. Those are the two big things that you need to be careful of when you're looking at categorical data. Okay? Thanks, we're done.